Well, you have found the derivative using rectangular coordinates. We have found the derivative using parametric equations. Now it's time to find our derivative in terms of polar coordinates. So let's just review. Remember how you defined in trig that cosine of theta was x divided by r. So multiplying by r on both sides, you get this. Similarly, you defined that the sine of theta was y over r, and so you get this equation. But now we have r is a function of theta. How can we find dy dx? You should know that dy dx is going to be dy d theta divided by dx d theta, just like in parametric mode when we did dt. Now we have d theta. So we've got to find dy d theta and dx d theta. Well, got to take a minute. Say, well, r is a function of theta. So we have to replace r with a function of theta. So I'm going to start with y because I want dy d theta. So y is a function of theta multiplied by the sine of theta. If I want that derivative with respect to theta, I'm going to have to use the product rule. So I'm going to have the first times the derivative of the second plus the second times the derivative of the first. Yep, that's just ugly. So let's do if x is also a function of theta times cosine of theta, then dx d theta, again using the product rule, we'd have the first times the derivative of the second plus the second times the derivative of the first. Ugly. So dy dx is going to be dy d theta divided by dx d theta. And no, there's really nothing you can simplify, reduce out. It's just ugly. So I have f of theta times the cosine of theta plus, I am going to just put this in front, f prime of theta times the sine of theta divided by, I'm going to take that negative sign out to the front, and again I'm going to take that derivative out in the front just to make it a little bit more consistent. So that is your dy dx in terms of polar functions. You can memorize it or you can just rederive it every time. It's kind of up to you. So in the first example, we're asked to find dy dx and the slopes of the tangent lines at the given values of theta. So we have two values of theta. Let's go ahead and find r. Find r when theta is 0. Well, r equals -1 plus the sine of theta. So I'm going to plug in 0. Well, the sine of 0 is 0. So I have the ordered pair r and theta to be -1 and 0. Where is that? Remember, that's not x and y, that's r and theta. So theta being 0 degrees, or 0 radians in this case, we would go backwards, not toward the angle, but backwards. That point is r is -1 and theta is 0. I know, that's weird. Okay, what about when theta equals pi? So we have r equals -1 plus the sine of pi. Well, the sine of pi is also 0. So we have the ordered pair -1 pi. Well, pi is over that way, but again I go backwards from it, and so this point is -1 pi. Go back and review the previous videos about how to plot polar coordinates if you are confused at this point. Alright, so now I need to find dy dx and the slopes of the tangent lines at the given values. So I can kind of just look at that and kind of draw, that's one tangent line, that's another one. So I need to find dy dx. So I'm just going to go ahead and plug it into that formula. Dy dx equals to my function of theta, that's r. So I'm going to have negative 1 plus the sine of theta times the cosine of theta plus the derivative of that times the sine of theta. So the derivative of negative 1 is 0 and the derivative of sine is cosine times the sine of theta. All divided by negative of my function multiplied by the sine of theta plus the derivative of my function, which I had found previously, which is the cosine, multiplied by the cosine of theta. And yes, that's just ugly. Okay, can we clean it up a little bit? Maybe. Would it help? I'm not sure. So I'm just going to leave it like that because it says find dy dx. Okay, I've done that at the given values of theta. So I'm going to first plug in 0 everywhere there is a theta. Okay, so when theta equals 0, dy dx equals negative 1 plus the sine of 0 times the cosine of 0 plus the cosine of 0 times the sine of 0 over negative of negative 1 plus the sine of 0 times the sine of 0. If it's okay with y'all, that's cosine squared of 0. Okay, so just to review, the sine of 0 is 0, the cosine of 0 is 1. So this is 0, this is 1. This is 1, this is 0. 0, 0, that's 1 squared. So let's do some arithmetic. So we have negative 1, so negative 1 plus 0 is negative 1 times 1. That's going to be 0. This is going to be negative 1 plus 0 is negative 1 times 0, still 0, and then plus 1 squared. So I have negative 1 over 1. So the slope when theta is 0, which is right here, is negative 1. That looks good. I should have had a negative slope. Right now, what about when theta is equal to pi? So same thing, negative 1 plus the sine of pi, cosine of pi. Okay, going back to review, what's the sine of pi equal to? 0. The cosine of pi is negative 1. So everywhere we see a sine, that's going to be 0, that's going to be negative 1, that's going to be 0, negative 1, 0, 0, and that's negative 1, and remember it's squared. So on top, that's negative 1 times negative 1 is positive 1 plus 0. All that is 0, and that's going to be 1. So when theta is pi, which is this point, our slope is positive 1, and that looks good. This example doesn't just ask us to find the slope of the tangent line, it asks us to find the equation of the tangent line. So what do we need for that? Well, we need dy dx, which is going to be the slope of the tangent line, and we also need an xy coordinate. So we're dealing with r's and thetas, so we need x's and y's. Well, you need to remember that x is equal to r cosine theta, just going back to trig. Remember, cosine is x divided by r. We know that r is equal to 3 plus 8 times the sine of theta. So now I need to evaluate it when theta is pi over 6. So we have x equals 3 plus 8 times the sine of pi over 6 times the cosine of pi over 6. So you really need to know that unit circle. The sine of pi over 6 is 1/2 times 8 is going to be 4. And then the cosine of pi over 6 is the square root of 3 over 2. So our x-coordinate when theta is pi over 6 is going to be 7 over 2 times the square root of 3. Let's look at y. Y is r sine theta. And again, substituting in what r is defined by as a function of theta. Now, evaluating this when theta is pi over 6. So we did this over here, so we know this is going to be 3 plus 4, which is 7, and then the sine of pi over 6 again is 1/2. So our xy coordinate is 7/2 square root of 3 and 7/2. What else do we need? We need to find dy dx, because remember that equation of the tangent line is y minus y1 slope times x minus x1. So I have my x and my y coordinate, just need to find the slope, which is my derivative. Okay, so I could go back and look at that formula and memorize it, or I can just do it from here. So remember, this is dy d theta over dx d theta. So I'm going to find dy d theta. So here is y. I just need to find the derivative. So again, how do I do that? I'm going to use the product rule. So I'm going to have the first times the derivative of the second plus the second times the derivative of the first. So the derivative of 3 is 0. The derivative of sine is cosine. Divided by, now I'm going to find the derivative of x with respect to theta. So again, just using the product rule. So I'd have the first times the derivative of the second, which is negative sine theta, plus the second times the derivative of the first, which I did already here, so that's 8 cosine theta. That's my ugly, ugly slope. I really would just say leave it. You can't usually do much with it. Okay, because we need to find the slope when theta is pi over 6. So really, I just need to put in pi over 6 everywhere there is a theta. And we've already evaluated. We know that the sine of pi over 6 is 1/2, and the cosine of pi over 6 is the square root of 3 over 2. So that's what we're going to need to know. Okay, so I have dy dx equals to 3 plus 8 times the sine of pi over 6, cosine pi over 6. Really took the long way to write it all out for you. Okay, first of all, don't do bad algebra. Okay, you cannot cancel this and this out on the top and the bottom because you've got plus signs. So don't be dividing anything out. Just evaluate. Right, so we know that the sine of pi over 6 is 1/2 times 8. That's going to be 4. This is going to be the square root of 3 over 2. This is 1/2. Square root of 3 over 2 times the 8. So this is going to be the same thing as above. This is going to be 1/2 with the negative. This is going to be the square root of 3 over 2 times 8 times the square root of 3 over 2. So let's see what we have. We're going to have 3 plus 4 is 7 times the square root of 3 over 2. Then I'm going to have, let's see, 1/2 times that is going to be the square root of 3 over 4. And don't forget to multiply it by the 8. So 4 is going to go to 8 twice. Divided by, that's going to be 7 times negative 1/2 plus square root of 3 over 2, square root of 3 over 2 is going to be 3/4. Okay, let's see if we can simplify that just a little bit more. So we have 7 square root of 3 over 2 plus 2 square root of 3 divided by negative 7/2 plus 6. Well, that's just ugly. Okay, I'm going to clean it up. I'm just going to multiply the top and the bottom by 2 to get rid of those fractions. So I'd have, let's see, 7 square root of 3 plus 4 square root of 3 divided by negative 7 plus 12. Okay, so some fancy algebra. Multiplying that, the 2's cancel out. That multiplies to get 4. 2's cancel out. That gets to be 12. And so that is my slope. Okay, what was my x and y coordinate? X was 7 square root of 3 over 2, and y was 7/2. So now I'm ready to find my equation of my tangent line using my point slope formula. Just ugly. I think I'm going to try a little bit more. Let's see. If I multiply that, let's see, I'm going to get a 10 on the bottom. 7 times 11 is 77. Square root of 3 times the square root of 3 is 3. Now that's just ugly. But you know what? I could add 7/2 to both sides. I'm just going to stop. Most of the time, the equations of the tangent lines in rectangular coordinates, not real pretty.